Hello Luan, this is FRQ number 10, and we're starting with part A, where it asks for a free body diagram on the block. So there's going to be f of A acting there. The block has f of G acting like this, f of N, and then over here is f of K. Okay. For part B, it asks to find the frictional force acting on the block. So to find the frictional force, Fk is equal to mu K times Fn. So in the block, Fn is equal to Fg, so we can write Fk is equal to mu K Fg. So the question gives us mu s, which is 0.2, and it also gives us the weight of the block, which is with 44.5 newtons. Now if you multiply this in your calculator, you should get around 8.9. So Fk is equal to 8.9 newtons. So part C asks for you to derive an expression for dx over dt. So dx over dt is the same thing as x prime of t, which is v of t. So to find v of t, we can integrate acceleration. So acceleration can be found with the formula net force over m is equal to a. So the force that's acting upon the block is 8t squared. Wait. The force acting on the block is the net force is Fa, the applied force, minus Fk, which is the kinetic force, over the mass. So the mass can be found by dividing the weight given, which is 44.45 over 9.8, which is equal to about 4.54 kg. You can find f of a is given to us as 8t squared. So if we plug everything in, it'll be 8t squared minus 8.9, which is the Fk, and you divide that by 4.54, and that gives you a of t. After dividing 8 and 8.9 by 5.54, you get 1.76 t squared minus 1.96 as a of t. Now to find v of t, you integrate a of t, which is equal to 1.76 t cubed over 3 minus 1.96 t plus c, and the c is equal to 4 because it says that the block is initially moving 4 m over s in the question. So I'm going to rewrite it as 4. So v of t is equal to 1.76 over 3, which is about 0.587 t cubed minus 1.96 t plus 4. Now question D asks to find the instantaneous velocity of the block when t equals 2. So to find that, you plug in v of 2. So v of 2 is equal to 0.587 cubed minus 1.96 times 2 plus 4, which is equal to 4.776 m over s when t is equal to 2. Okay, so for E, it's asking for the instantaneous speed of the block when it is at position x of t equals 2 meters. So to find this, you can integrate. To find the x of t function, you integrate the velocity function. So the integral of the velocity function will be 0.587 t4 over 4 minus 1.96 t squared over 2 plus 4 t plus c. C is 0 because it says x of t at 0 is 0 meters, so c is 0. So this is the same thing as, so x of t is equal to about 0.147 t4 minus 1.96 minus 0.98 t squared plus 4 t. So the question asked to find the instantaneous speed when it is at the position x of t equals 2 meters. So he set x of t equals to 2, and he set this equal to the function. You subtract 2 by both sides, and then you plug in, you use a polynomial solver in your calculator to find when t is equal to 2. So it gives 4 answers, but the most plausible one is 0.577 seconds, because you can't have an I in your time, and time can't be negative. So to find velocity, you plug in, to find instantaneous speed, you plug in v of 0.577 is equal to 0.587 0.577 cubed minus 1.96 0.577 plus 4. And this gives you about 2.98 meters per second. Now to find average speed for the 8 seconds of motion, you can take the integral. You take the integral of the absolute value of vt. So s average is equal to the integral from 0 to 8 v the absolute value of v of t dt. And you divide by 8 because it takes 8 seconds, and this gives you 71.29 meters per second. So for G, it says to find the velocity to graph the velocity of the block. So this is velocity. Let me change it to a thinner one. So this is velocity. This is velocity, and this is time. So to do this, you can graph as 0, 0, and then 1, 2, 1, 2, 3, 4, 5, 6, and wait, I'm gonna change it to 2, 4, 6, and this is 8. So to do this, you have to, you plug it, you graph it on your calculator, which I can't show you. So you just graph in your calculator, you graph v of t on a calculator, which is 0.587 x cubed minus 1.96 x plus 4. Then you graph that. So this is about so the top here, that's 288 was 208, 128, 48. So at 0, it's at t equals 0, it should be at around here where 4 is. And then it slowly decreases. Slowly decreases, and then at around, and then it starts increasing, and then it should end up like around like this. And that's FRQ number 10.